Hey guys, and welcome to day 12 of our online learning. Today we're going to finish up our gravity unit, so we'll be taking a quiz. It's 10 questions on gravity today. A couple things. So number one, I'm going to explain sort of what the assignment is, and then afterwards, if you would like to sort of stay on board, I'm going to go through a small short review, which I guess we'll see how small it is. A couple things. So number one, this is your only thing to do today is to take the assessment right here. Rubric is also posted. There is no actual attendance form this time. So I'm just going to say like, hey, as soon as I get your Google form in, you're good. I can sort of go back and change this as we get things turned in. But if for some reason you don't think that you're going to be able to take this in the allotted time, then just send me an email, let me know what's going on, just checking in, and I will count you present. All right. A couple things. So also, which if we can take a brief look at our calendar real quick, then as you guys know, these 2 days, so Thursday and Friday, and then this is the end of our gravity unit. So this is going to be our last assignment for seniors. So seniors, this is what's going to happen. And I will be sending you a personal email about this also with more details. But this is our last assignment. This is the last grade that you will get counted for. And then the 4th and the 5th are going to be designated as makeup days. So if you have any assignments that you have that are ends in the grade book, that are for a grade, then this is your time to work on them. If you are completely caught up, then you have 1 to 2 options. You can just call it good and be on about your merry way, and hope you I'll save it for the emails. Or if you would like to go back and any grade that is assisted, not unassisted, but any grade that is assisted that we have taken since online learning, if you want to improve any of those to bump up your grade, especially if you have a borderline grade, then that might be a good thing to do on one of these 2 days. All right. On the 6th, you turn in your Chromebooks to school. I hope to see you all up there. I will be like all the other people in my car wearing a mask, but very, very excited and proud of you and just waving from inside. I don't know. Maybe I'll bring my dog up. He would like that. All right, so let's take a quick look at the assessment. Let me turn it on student mode. Oh, they always do this. Okay, hold on for just a second. I got 2 screens now. That's pretty cool. Just saying. Okay, so we'll bring that tab over, this tab. Okay, let's go through just a couple things on the quiz. So first, there's 10 questions. It logs your email address, so know that. There's also a feature turned on to where, okay, so let's just go through this. You can use notes, you can use slides, you can use information from past assignments, because there was probably a reason I assigned it to you, right? But it does sort of register if you got information from other sources. I will not explain further. Just know that that's like a feature on there. And yeah, just do your best, okay? You might need to refer to this equation, the law of universal gravitation. There are 2 math problems. We'll go into what those are going to kind of look like. So force of gravity is what you will be solving for. That gravitational constant is still the same, 6.67 times 10 to the negative 11th. The mass of one thing times the mass of another, and divide all that by r squared. More on that in the notes section. So let's see. It's all multiple choice except for one question that I just couldn't figure out how to make multiple choice and just didn't want to put the energy in it. They're all worth 1 point each. And a quick thing about the math, all right? So number 1, if you solve these, see, here's the thing about multiple choice, both math and physics exam. We are probably not going to get the exact same number, and that is 100% okay. If we were cooperating on an international project that involved a lot of extreme precision, then that would matter, but it doesn't, so it doesn't matter. So if you get a number with different significant figures, if you rounded slightly differently, then you might not get one of these numbers. That is okay. This isn't later. Let's say instead you're just a couple of numbers off, but it's close. Like instead of being this number, it's like 4 point something, but it's to the correct power. That's probably the correct answer for you. All right. I tried to make these far enough apart to where one answer was more obvious, but they're also the answers you would have gotten if you did the formula incorrectly. That's all I'm saying. All right, and other than that, all right, that's the quiz. Okay, so 10 questions. Do that. As far as the rubric goes, because my physical science students kind of freak out a little bit, don't forget, our scale starts here at a 5, all right? So if it feels like you did really badly, it might not be as bad as you had thought. There are no redos for quizzes. I can't open it back up for you, and I will not take it if you do it twice for whatever reason. Instead, focus on bringing up assisted grades, like that Kepler's Law project. That was for a grade. You know why it was worth an easy 10 points? Maybe to boost up the quiz at the end of the week. Yay, you're welcome. After this, starting next week, we're going to do a few weeks of electricity. More on that to follow, so I'm going to try to make it applied as much as we can, but a little bit of math. So, applied but math. Here we go. All right. For everybody who is just ready to just dive right on in and take that quiz, you are good. Stop the video and go ahead and take it. For everybody else, we're going to do a quick review. So a couple things. Let me get rid of all of my tabs or just pull them over here. Where did the other one go? Oh, it was just hiding. Okay, there we go. All right, so let's start from the beginning. I wrote myself a list of things to make sure to mention to you. All the things. Gravity, there's 4 forces. There's gravity, there's electromagnetic force, there's the strong nuclear force, and the weak nuclear force. The most kind of gravity is the weakest one, but it's also kind of the strongest. It's weak in the sense that it takes an incredible amount of mass and very large or very small distances to really matter. But it's also the force, like you guys learned in the Cosmic Explosions article, that has sort of shaped everything in our universe, right? Like gravity is the reason that we have planets and solar systems and galaxies. And if we didn't have those things, then life would never have developed on this planet, because there wouldn't be a planet, because you can't have life if you are just not even a rock floating out in space. You're just cosmic debris. Ugh. So gravity is one of those 4 main forces. It's the weakest, and it's the one that says one mass is attracted to another mass based upon the size of those masses and the distance between them. For gravity, those are the only 2 things that matter: mass and distance, not anything else. All right, a couple of things about Newton's law of universal gravitation. So number 1, constant, just keep it the same. Number 2, many of you will forget this. In fact, when I was first doing these practices, I occasionally forgot it. It's an easy thing to forget. Square your denominator or everything will be wrong. Square it. Other things, let's see. Okay, so the fact that distance is down here and is being squared and masses are up here and being multiplied means that distance in this form is what we call the inverse square law. Well, yeah, it's hard to correct yourself mid-video. Okay, so according to the inverse square law, what it means is that things in the denominator that are being squared have an inverse relationship. So the force of gravity goes up as mass increases, right? The gravity between planets is greater than the gravity between this pen and this calculator. Not very good. And that's because one has a very large mass and the other 2 do not. However, even though mass affects gravity, the thing that's a real kicker is the distance. So if I double the mass, I double the force of gravity. But so first off, the distance is an inverse relationship. So as the distance between two things goes down, the force of gravity gets bigger, right? So as we get closer to really big objects, the force of gravity of those objects on us increases. So they're inverses. As one goes up, the other one goes down. So as the distance between objects gets smaller, not only does the force increase, but it gets way bigger, 4 times. 4 times. So making the distance smaller is always going to have a larger effect than the mass. Okay? Just very important. Alrighty. What else? Yeah, so universe was shaped, weakest force, we talked about it. Oh, inverse square law. Hey, I have it all written down, like right here. Decreases rapidly with size. Takes a planet's size and mass to notice the effects of gravity. So we all have a gravitational pull on the objects around us. However, that force is so small, as you guys were able to calculate, it's like 10 to the negative, like 11th or something, or 10th, maybe, on those 2 grapefruits. So like it existed, but when you're talking 10 to the negative 11th, nothing really matters. I mean, not at least on the level that we sort of have our senses on, that we're able to see and touch and feel. Okay, it's really stormy out there. Awesome. All right, gravitational fields, Cavendish experience. Black holes are super cool. You should read more about them later. All the cool things. That was just, yeah, okay. Maybe review this slide just a teensy bit. That might be a helpful thing for you. Kepler's laws, which you went over yesterday. A couple different things. Number 1, planets follow an elliptical pattern. So again, it's just a squashed out oval. Planets circle around the sun kind of in a pattern that looks like an avocado. That's it. Yeah, that's first law, super easy. It's kind of like it's like a red herring. Is that what that's called? Red herring. Makes you think that the rest of the laws are going to be just as simple, and they're not. So there you go. Number 2, as a planet moves in its orbit, it sweeps out an equal amount of area in an equal amount of time. What does this really mean? It means that planets speed up and slow down as they orbit around the sun, and they are the fastest when they're closest to the sun. The reason for that is because, again, if we think about distance having the largest effect on the gravitational force, then if it is really, really close to the sun, then it has increased the force. And what is a force? It's a mass times an acceleration. So planets accelerate the closer they are to the sun because it is exerting a greater force upon them. Boom. Check that out. So planets go through the equal area in the same amount of time. Our third law basically just says that the period, the time for one cycle, so the year length, the number of days in a year for every single planet divided by sort of a ratio here. This is squared and this is cubed. The length of that axis for that planet, sorry, I'm a little flustered, is going to give you a ratio, and that ratio is the same for all planets. So the number of days for Earth versus the number of days for Neptune are equal in ratio to the diameter of their axis. I think that's the best way to say that. Sorry, kind of murdered that one. Review the video. That might be a good idea. Also, their video on your other Kepler's laws thing. Hold on. Where's that at? Do you ever have just too many tabs and your life's just kind of falling apart here? Okay, it is right here. Oh wait, no, that's my video. This one, Orbits and Kepler's Laws by NASA, also gives you a good review. Okay, And that is it. All right. So do the quiz, get all the points, do your best, get easy hundreds, kick science's butt.